All right, so square root, the square root symbol is getting some of you. Okay, what does square root mean? Anyone know what that means? You've seen it since elementary school. You did it in middle school. You did it in Algebra 1. But what does it mean? Hello, is my mic on? Half of something. So this means half. So then the square root of 16 is 8. Is that what you're saying? So that means if we're doing half, the square root of 16 would be 8. And the answer is no, it's not half. Good guess, though. Good guess. And so, because the square root of 16 is not 8, the square root of 16, and some of you did send it to me in the chat, and you didn't have to, it's okay. The square root of 16 is 4. And so someone else says, Mister, does it mean divide? Divide by what? So another guess is divide by itself. So 16 divided by 16 is 1. So you divide it by itself. So that means if I divide this by itself, I would get 16 divided by 16, which is 1, and that's not the answer. So no, it's not dividing. Good guess, though. Good guess. So this is why I wanted to go over this, because I know some of you were taught square roots, but were not taught exactly what it was, right? What does it mean? Someone says find a number that if you multiply it by itself. So someone says find a number that if you multiply it to itself, and then that's all they said. So that's a little closer to what we're doing. We need to find a number that if you multiply it to itself, you get the number inside. And so let's think about it. What's 4 times 4? 16. Okay, but why do we call it a square root? Why square root? Right? This is a long way to say a definition, isn't it? This is a long way to say a definition. So how do we say it a little nicer? Right? How do we say it a little nicer? Well, this is the square root symbol. Right? Oops, let me write it better. Square root. And this is correct. You have to find a number that if you multiply it to itself, you get that number, because 4 squared is 16. But let's get a nicer way to say this. Right? We can rewrite 16 as 4 to the second power, right? 4 to the second power. Everyone agree with that? 16 is 4 times 4, which is 4 to the second power. What a square root is it cancels out a squared. You guys know that a number to the second power is squared, right? Well, a square root cancels out with a squared. So this and this cancels out, so that's why we're left with 4. It basically just, a square root cancels out a square. It's the root of a square, right? So it just cancels it out. So you have to know your squares. Do you know your squares? This is one thing you need to know, so that way you know what cancels out. Do you know your perfect squares? You should know them from Algebra 1. If not, if you forgot them, you're definitely going to need to know them for Algebra 2. Right? Like, what's 1 squared? 1. What's 2 squared? 4. What's 3 squared? 9. What's 4 squared? We just did that one, 16. What's 5 squared? Mister, are you going to go through all of them? I'm going to go through a few. 25. I want to see how far you guys can go till you stop. 6 squared. 36. Very good. 7 squared. 49. 8 squared. Right? This all should have been done in not elementary school, in middle school, right? You should have done all this 64. And some of this is coming back to you. Some of you are going, oh yeah, I remember these numbers. 9 squared. Right? A lot of you are getting these numbers right now off the top of your head without having to look anything up. 81. Ooh, 10 squared. That one's easy. 100. Very good. 11 squared. Uh-oh. A few of you are gonna forget this one. What's 11 squared? Someone said 110. Ooh, close. Close. 121. 100 what?
21.
Yes, thank you. 121. Okay, what's 12 squared? Uh-oh. This is one, remember when you were learning multiplication tables back in 3rd grade? This was the last one at the end of the table. 12 times 12. 144. Very good. Now, this is where I'm going to get a lot of people that don't know these. And you should know these next few. What's 13 squared? Someone guessed 158. Close. Oh, now we're getting to 169. Very good. We're getting to a spot now where it's not memorized, and it's okay. What's 14 squared? Anyone know that off the top of their head? You can use it. 196. And the way you know those ones is 13 squared is 169, and then the 6 and 9 switch. The 14 squared is 196. Anyone know 15 squared? $225. Very good. I'll be stopping soon. And then 6. Let's just stop at 16 squared. What's 16 squared? Anyone know 16 squared? 256. Very good. Okay, so all these numbers, when I square a number, the result, so all these numbers that you got here, these are all called perfect squares. They're called perfect squares because they come from squaring a number. So if I asked you what's the square root of 49, you would say that is 7. And the reason, this is the, hold on, wait for it. Haven't played this in a while.
Tell me why.
Right? A lot of you didn't ask the question. You guys just said, oh, square root of 49 is 7. Square root of 36 is 6. Square root of 81 is 9. You just knew that, but you didn't know. You didn't tell the teacher.
Tell me why.
And the reason why is because 49 is a perfect square, right? And you are asking yourself, hold on, someone's coming in. Please try to get here on time, everybody. And it is correct to say a square root means what number? Oh my gosh, hold on. Someone else is coming in. What number times itself gives me this number? And that's correct. That's what a square root's asking. What number times itself? Right? A number times itself gives you that number. So that's a proper way to think of it. Another way to think of a square root is we can rewrite 49 as 7 squared because it's a perfect square. And then we know a square root and a square are opposites of each other. Right? When you square a number, you multiply it to itself. When you square root a number, you're trying to see what number times itself gives you that number. So then you can just rewrite 49 as 7 squared, cancel it out, and that's how we get 7. Okay? So if you're thinking, okay, let's try one. What's the square root of 225? Let's try one more. Square root of 225 is what? What's the square root of 225? Hello? 15. Yeah, square root of 225 is 15 because, remember, 225 is 15 squared. So if we think about it, what number times itself gives me 225? 15. Or if you want to think of it the other way, square root of 225, well, 225 is just 15 squared, and the square root and the square cancel each other out. So that's how we get 15. Okay. Mister, yeah. What if I want to find the square root of numbers that aren't those perfect squares? Like, let's say I want to do the square root of 5. Square root of 5. Well, the square root of 5 is in between here, isn't it? It's in between 4 and 9. It's somewhere in here. So that means it's going to be somewhere between 2 and 3. Or, guess what you can use? Just use a calculator, and it'll give you the decimal. Because doing it this way, you'll know, oh, it's somewhere in between here, because the square root of 4 is 2, and the square root of 9 is 3, and the square root of 5 is somewhere in between there. Closer to 4, but somewhere in between there. Use a calculator, and you'll see it's 2 point something. Okay, so yeah, so if you get a, I'm going to show you later how to simplify radicals, right? We're going to simplify radicals, but that comes later. From now on, if you get a number that's not a perfect square, that's not one of these numbers, and you don't get a whole number as an answer, just use a calculator and you'll get a decimal. Okay, I'm fine with that. Okay, does that make sense? Any questions on what square roots are? Right? Square root means you can look at it two ways. It means, like someone said in the chat, thank you, what number times itself gives you this number. Or a square root cancels out a square root cancels out a square. Squared, right? So this exponent, right? The exponent, 2. So it cancels out an exponent of 2, a squared. Okay, any questions on that? And then these are all your perfect squares. You should know these perfect squares. You should, when you see 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, when you see those numbers, you should say, oh, that's a perfect square. So I can take the square root and get a whole number. Okay. All right, let's look at number 2. So first, let's do what's inside the radical, right? This is a square root sign, but it's also called a radical sign. And yes, that's what we used to say back in the 80s, radical. But it means the square root sign. So let's do what's inside the radical first, and then we'll take the square root. So what's 25 plus 24? What's 25 plus 24?
21.
No, it's not 21. 49. So this becomes the square root of 49, which is, well, we know 49 is a perfect square, so that's the same thing as saying 7 squared, right? And then that cancels with that, so we get 7. Okay. I need you to understand this. Some of you are like, Mister, I don't do this. I don't do the changing the 49 to 7 squared and canceling it out. Well, if you don't do that, that's okay. Because some of you say, Mister, I just go from here to here because I know 7 times 7 equals 49. That's great. But I need you to understand this concept, that a square root cancels out the power of 2, which is called squared, right? The power of 2 is called squared. And it cancels it out. I need you to understand that because later on when we simplify radicals, you're going to need to be doing this. Okay? So yes, the middle school way of understanding square roots is what number times itself gives you this number. Perfect. That works. It's a definition and it works. High school definition, I need you to understand it's a opposite of putting something to the second power, of squaring something. And that's why they cancel out, and that's why you're just left with this. Okay? Because we're going to be using that later on. For instance, like this one, number 3. Let's do what's inside first. Oh, some of you are like, Mister, can I do this? You said it cancels. Can I do this, this, and this? Can I do that? And the answer is no. No, you cannot. Because of this plus sign. We're adding something together. The only time we can do that is when it's by itself, when we cancel like this. Right here, we have a plus sign. Oops, we have a plus sign right here, so we need to add those together. So let's do this first. So square root. So what's 3 squared? We do that first. What's 3 squared? That's 9. Plus, what's 6 squared? Hello? I need you guys to participate. Come on. What's 6 squared? 36. Very good. I need some new people to participate. I'm getting the same 5 or 6 people participating. That's how you get better at this, when you participate, when you actually put yourself out there. Okay, and so what's 9 plus 36? 45. And so 45 is not a perfect square, is it? It's not a perfect square. When we look at our list of perfect squares, it's not there. But where is it? 45 is about right here, isn't it? It's in between 36 and 49. So 45 is here somewhere. So that means my answer is between 6 and 7. So if you say 6 point something, you're right. It's in between, because square root of 36 is 6. The square root of 49 is 7. So the square root of 45 is somewhere in between there. Right? But you can get your handy dandy calculator and just do your square root of 45. Now, some calculators are different. Sometimes you got to put square root and then hit 45. Sometimes you got to put 45 and then hit the square root sign. And I get my answer as 6.70820393324. Do I have to say that many? 6.7 is fine. 6.7 is fine. Okay? And we know that's right, because if we go over here to our list, it makes sense, because 45 is closer to 49. So that means it's closer to 7, because it's in between here. So 6.7 sounds about right. Okay, so just use your calculator when you have a number in here that's not a perfect square. Later on, and here's a sneak preview. I'm going to show you a sneak preview on what we're going to do. You don't have to write this down, but here's a sneak preview on what we're going to be doing later. Sneak preview. You do not have to write this down, but that's a sneak preview on how we're going to simplify radicals later. Okay? Do not have to write this down. Do not have to know this now. This over here is fine. Use your calculator. And it works. This works way better in real life, right? This, in real life, we don't like this. This is very mathy down here. This little sneak preview that I'm going to show you later, very mathy. Doesn't help in the real world. This helps in the real world. If I need to know, because my brother, he works in construction, but it's like the interior of the construction. So he builds up offices and stuff, and he's sending me questions all the time. And he works with right triangles a lot. He works with right triangles a lot because, you know, corners of things, corners of offices, corners of desks, corners of something he's trying to install inside an office. So he deals with a lot of corners with 90-degree angles, and he needs that diagonal. So he calls me. He's like, "Oh, what's the square root of 72?" Right, and I have to tell him, and then we talk about it, and then this wouldn't help him if I told him this. If he called me and said, "Hey, Mike, what's the square root of 45?" and I say, "It's 3 square root of 5," that wouldn't help him because he's building something, right? He needs an actual measurement. So I'd actually tell him this number, so he can go as far as he wants in accuracy. So he'd probably go like this in accuracy because he needs to measure almost exactly. This might mess him up, so he might have to go this far in his accuracy. But yeah, so this, in real life, this is what you do. Just punch into a calculator, get your answer. Okay. Later on, we are going to do this. This is a sneak preview into what we're going to do, something mathy, but it's not very real world. Not very real world. All right. Any questions on the warm-up? Square roots. If you can find the square root of a perfect square, and you should know these numbers should stay in your mind. When you see these numbers, you should say, "Oh yeah, that's a perfect square." Even these ones, 12 squared, 13 squared, 14 squared, 15 squared, 16 squared, you should know this. Does anyone know? Did anyone try 17 squared? Did anyone try 17 squared? You should know. You should, by the time you get to algebra 2, you should know up to 25 squared, which is 625, by the way. You should know that just so you have some recognition of perfect squares. It helps. Does anyone know what 17 squared is, by the way, before we move on? No, it's not 21. What's 17 squared? 289. Very good. 289. Just for those of you that wanted to know. 289, another perfect square. All right. Are there any questions? Any questions? Okay. I brought back our agenda. I took it off for a while because some of you are telling me there was too much going on. So I just have two things going on now: the objective and the classwork or homework. Okay. Today's objective. What is today's objective? And the date, of course, in case you forget the date. I know sometimes we forget the date because we've been in our houses for a year and all the days blend into each other. And there's been so many times I've woken up on Saturday like, oh my God, I'm late. I'm like, oh, wait a second. Today's Saturday. Never mind. And so it is Wednesday. It is hump day, middle of the week, right? April 7th. And today's objective, we're going to review the Pythagorean Theorem and use it to find side lengths of right triangles. Okay. So today we're going to focus on just triangles that are floating in space that don't mean anything. Tomorrow, we're going to apply it to real life situations because we see this a lot in life. We see a lot of right triangles in life. Like I was telling you about, like my brother, right? And then our homework is a Pythagorean Theorem and applications homework, which is due on Friday. We will have a classwork tomorrow to practice what we're doing, okay? All right, so if you go to Schoology, Mister, you show us this all the time. Yes, because some of you need constant reminders. Some of you, just like me, forget. My sons are always telling me, Daddy, I just told you this. How did you forget? I'm like, there's a lot going on in my mind, and sometimes I forget. And so I know that's going on with you guys. So go to Schoology, go to our course, and then go to week 12. If you look here, week 12, that's this week. And you'll see the video from yesterday, right? The video from yesterday, which is the last video I did on similarity. Please look at that if you need to finish that work. And then you see here is the notes, and then the note solutions. Again, we do not turn in notes. But mister, it says it's due today. Yes, it's because the only reason I put a due date for the notes is because some of you like to write it on Kami. So you click on this, and when you see here on view, next to view, if you're in Chrome, it should say open with Kami, and some of you like to take your notes on Kami. That's why I did that. I'm saying this again for the millionth time because some of you need to hear it a million times. The notes you do not turn in. Okay? It's an assignment, but it's an ungraded assignment. Has no point value. Do not turn it in. The homework here is due by Friday, and that's the Pythagorean. And I think there's only 11 problems. If we look here, I believe there's only 11 problems in the homework. Oh, 10 problems. There's only 10 problems in the homework. Okay, so not that bad. Okay, so I'm going to give you a minute to go over here and get your notes, print them out, open them up in Kami, open them up in a new tab. However you do it, I'm going to do this. I'm going to give you a minute so you can do this. Open up your notes, and there's the notes. It's only 2 pages. Really easy notes because this is something that we've learned before. This is something that we learned before. And yes, if you look here, there is one called Note Solutions. So if you miss something or you just want to look at notes, there are notes here. And it has all the solutions to everything. Okay? So I'll give you a minute to get your notes. I already have them pulled up here. So this is what you should have. So I'll give you a minute. Let me put a timer. A lot of you like your timers so you can see exactly how much time you have to do something. So there you go. Give you a minute. So someone just asked during the minute of getting your notes together, Mister, how do you write? Because if you notice, I can zoom in and write on this PDF, and this is just the same PDF that I gave you guys, right? But I load this into an app called GoodNotes, and I like it because I have a toolbar and I have a bunch of tabs that I can jump to my different documents and then zoom in. So but you can't see any of that because I'm broadcasting it to you, which I like. So when you present it, you don't see all my tabs and everything. But this one costs money. So some of you do have iPads. And you could go to the App Store. Let's see. You can go to the App Store. Oh, what happened? And then search for Notes. Notes. And you'll find a whole bunch of, look at this. There's Notes. That comes with the iPad. It's called Notes. There's Notability, Good Notes. That's the one I have, Good Notes. Notability, I think that costs. There's some that cost, and there's some that are free. But yeah, a lot of these you can get, and then you can load in your PDF. You could go here to Schoology. You could download the PDF, and then you can open it with your Notes app. And then your Notes app, you'll be able to do stuff like I'm doing here. And then if you don't have because some iPads, the newer iPads, you can use an Apple Pencil, and that's what I'm using. I'm using my Apple Pencil. But some of them you can just use your finger. Some of them you can use a stylus. I know they sell styluses at the 99-cent store that are way better than they used to be a few years ago. And that might be a way to go too. Yeah, I love my notes. I take notes. Even when I go to meetings and stuff, I hate paper. I just take all my notes on here, and then I have tabs. And I have, can you see my folders when I do this? You can't, huh? So I can even look through my folders as I'm doing now I can't get back to where I was. Oh, come on. Okay, hold on. Now I'm lost. I went back to my folders because I wanted to show you that there's folders, and I can't get back to where I was. Okay, there we go. All right, any questions? Any questions? So yeah, so if you want to write like kind of like I do on your iPad, just look for a note app. I use my iPad. I don't know if it works on if you have a Chromebook with a touch screen. I don't know if you have your own Chromebook. But if you have a Chromebook with a touchscreen, you might be able to get an app there, but you'd have to go to the Google store to get that. But yeah, if you have an iPad, you can just download an app, a notes app, and there's a lot of free ones, and then you can load in the PDF of the notes, and then you can just use your finger or an Apple Pencil or a stylus to write in like this. Yeah? Okay. Pythagorean Theorem. This guy named Pythagoras, long time ago, came up with this theorem. And there's many proofs to this theorem. I think I spoke to you about this yesterday, right? I told you James A. Garfield has a proof for this theorem. Remember what I told you yesterday. Theorems started off as theories, as a guess as to how something works. And then people came up with ways to prove that it is true. Because if you have a theory, you have to prove that it's true before it becomes, something we can use. Right? So the Pythagorean theorem, if you Google proof of Pythagorean theorem, you will see so many ways that this has been proven. Okay, and we will go over one this week. But yes, all it's basically saying, Pythagorean theorem only works for right triangles. And all it says, now some of you know it as, when I hear Pythagorean theorem, a squared plus b squared equals c squared. Okay, great. But a, b, and c, what are those things? So what are we doing? What do we use the Pythagorean theorem for? Well, we use the Pythagorean theorem to find the missing side length of a right triangle. Oops. Okay, so we use the Pythagorean theorem so we can find the missing side lengths of a right triangle. Okay, so there's 3 sides to a triangle. If I know 2 of them, I can use the Pythagorean theorem to find the third. Okay, so now you learned it as a squared plus b squared equals c squared. I want you to kind of throw that out of your brain. A and b, don't think of them as a and b. Those two sides that form the right triangle are called your legs. Okay, so sides A and B are called legs. Okay, and then the long side, you see this so the longest side of a right triangle, the side that's opposite the right angle. What do we call this? We call it C, I know, but what do we call it? What's the official name of it? That long side of a right triangle. Anyone know? Hypotenuse. It's called the hypotenuse. Okay, that's the longest side. So you know it, or you used to know it as a squared plus b squared equals c squared, and that's fine. But I want you to remember it as leg squared plus leg squared equals hypotenuse squared. Okay? A squared plus B squared equals C squared. That's the middle school way of knowing it, of remembering it. But A, B, and C are just letters. They really don't have any meaning. You should know it as leg squared plus leg squared equals hypotenuse squared. Right? And the legs are the two sides that form the right angle. And the hypotenuse is that long side. This is the hypotenuse. Is that long side. Any questions? Any questions? Now we're just going to use this formula, this theorem, the formula that comes from this theorem, to find missing side lengths of right triangles. Okay, so I'll give you a chance to copy this down. Hopefully this is refreshing some of your memories. Some of you are going, oh yeah, I remember a squared plus b squared equals c squared. But again, what is A, B, and C?
Tell me why.
Right? What is A, B, and C? Well, A and B are the legs, the two sides that form that right angle. Those are the legs. Because sometimes your right triangle might be twisted or turned or upside down. And so as long as you know that the two sides that make that right angle are your legs, and then the long side across that right angle is that long side is called your hypotenuse. And so the formula is leg squared plus leg squared equals hypotenuse squared. Okay, it looks like time is almost up, so we're going to stop here for today. Tomorrow we're going to use this formula to actually find lengths of sides that we don't know on a right triangle by using leg squared plus leg squared equals hypotenuse squared, which is the Pythagorean theorem. Okay, are there any questions though? Any questions? If you are not understanding this, please ask. If you are not copying this down, please copy. Okay, hold on. Someone has a question. I got to pause the recording. So the question was basically about leg squared plus leg squared equals hypotenuse squared, kind of a little more clarification on that. And so I just was telling you that, yes, we can label A, B, and C being the long side, and we can just say, oh, A squared plus B squared equals C squared. But that's the element, the middle school way of remembering it. It's more useful to remember that the two sides that make this right angle, that form this right angle, are your legs. And then the long side that's opposite the right angle is your hypotenuse. And so you need to remember it as leg squared plus leg squared equals hypotenuse squared. Because your triangle doesn't always look like this. Right? I remember I had a student, when I drew a right triangle like this one time, they're like, Mister, is that a left triangle? Oh my God. I hit my forehead. I said, no, that's still a right triangle because it has a right angle. And you may have a triangle that's upside down like this, right? You can have it any orientation, right? So as long as you know, oh yeah, this side and this side form the right angle. So those are my legs. And then this long side over here, that's on the other side of the right angle, that's my hypotenuse. And so it's leg squared plus leg squared equals hypotenuse squared. That's your formula. You use that formula to find side lengths that you don't know of right triangles. And we'll do that tomorrow. I just wanted to reintroduce you because you have met the Pythagorean theorem. I just wanted to reintroduce you to it. Okay. Are there any questions? Are there any questions before we end for today? Yes, the homework is due on Friday. You can start tonight if you want to, but we haven't done any problems. We haven't done any examples, so you can wait. What are side lengths? Lengths of sides. Lengths of sides. Right? These are side lengths, 8, 13, and something we don't know. So if we look at example 1, a side length is exactly what it says, a length of a side. A length of a side. Someone asked before we leave, what's the square root of 441? The square root of 441 is, hold on.
21.
I think someone just wanted me to play that. All right, if there's no other questions, we will continue tomorrow to use this formula to find some side lengths of some right triangles tomorrow. Okay? All right, take care, everyone. I'll see you tomorrow. Have a great day.